Here we have geometry problems part 4, and here we are looking at angles and again different formulas that I discussed earlier. So here's one problem that goes along with it. Determine the sum of the interior angles in a heptagon. So again, looking at this term heptagon, although we may not know exactly what it is, like we know hexagons are more common, it's 6. Hepta means 7. And so really heptagon means a figure that is 7-sided. So when we have to find the sum of the interior angles, again, for any polygon, doesn't matter how many sides it has, we always use the formula 180. We use the formula 180 times n minus 2. And so you always want to keep this formula in mind. And really, so looking at this formula, we know that a heptagon has 7 sides, so we just substitute 7 in for n. 7 minus 2 is 5. 5 times 180 is 900 degrees. So that is our answer here. And again, it doesn't really state if the heptagon has all sides that are of equal length. So we really don't know that. However, in the second problem, it clearly states that assuming that it's regular, determine the measure of each interior angle. And so looking at that, I mean, obviously for the first one, it didn't really matter. We just had to find the sum. But for the second one, it states that it's regular. And what does this term exactly mean, regular? In geometry, regular exactly means that the polygon has sides that are of equal length and angles that are all congruent in measure. Therefore, if we know that the sum of the interior angles of a heptagon, or in a heptagon, is 900 degrees, then the measure of each interior angle must be 900 degrees divided by 7. And so we round this value and we realize that this is 128.6 degrees. So that gives us the measure of each interior angle. And now for part 2, it says determine the measure of each exterior angle. So what happens is with this, technically we can determine this by subtracting this value from 180 degrees, because the sum of the interior angle and the exterior angle for a particular shape is always adds up to always being 180 degrees. Really, if I go back, the formula that I had earlier shown was to determine the exterior angle, you just do 180 minus 180 times n minus 2 divided by n, assuming that the polygon is regular, because n minus 2 times 180 gives us the sum of the interior angles. Dividing that by n, we get the measure of each interior angle, and then subtracting that value from 180 degrees, we can determine the exterior angle. So really in this case, if we subtract 128.6 from 180 degrees, we see that the measure of the exterior angle is 51.4 degrees. So 51.4 degrees is a measure of the exterior angle. However, there's another, I guess, an easier method if you don't want to go through the process of first computing the interior angle. Really, if you know that the polygon is regular as specified in this case, you really just do 360 divided by n, n in this case being the number of sides. So you know that the heptagon has 7 sides. To determine the measure of the exterior angle, you would do 360 divided by n, or in this case, 360 divided by 7. And that also gives us 51.4 degrees. So you can really use any method you want. But again, two main formulas you're going to keep in mind are 180 times n minus 2 is the sum of the interior angles. And then 360 divided by n gives the measure of each exterior angle in a polygon. So that's also important. Obviously, you can use this and then really find the exterior angle using this. And so it makes sense, because really 360 divided by n means that as you're increasing the number of sides, if you increase the number of sides, the denominator value gets larger, which means that each exterior angle, right, will become smaller. And so that makes sense. I'll show a demonstration later of why this is true, but for now, we can also find the number of diagonals in a heptagon, and I think that's important as well, because I earlier talked about diagonals, and there's another formula that goes along with that. So let's look at that. So we have again, let's just say we have the heptagon and we want to find the number of diagonals for that figure. We use the formula n times n minus 3 divided by 2. You just keep this formula in mind. You can find the number of diagonals in any shape. So if we were looking at a heptagon, we're really just doing 7 times 7 minus 3 divided by 2. That is 4 times 7, 28 divided by 2, giving us 14 diagonals in a heptagon. And so now that's just a formula for number of diagonals. When I was talking about the exterior angle stuff, it's 360 divided by n. So clearly, if we increase when we're looking at the exterior angle is really something like that, right? That's what it is. If this is the interior angle, this is the exterior angle, and clearly the sum of the exterior angle and the interior angle add up to 180 degrees because it's really a straight line here, so that's why it adds up to 180 degrees. However, if you were to increase clearly with a triangle, you have 3 sides, you do 360 divided by 3 and it's 120 degrees, and that makes sense, this being 60 degrees here. Assuming that the triangle is regular, which means that if it's regular, all sides and all angles are equal. Therefore, we know this is 60, this is 60, this is 60, and if we were to extend any straight angle here, this would be 120 and this one would be 120, and so 120, 120, 120 gives us 360. But the point was that if you increase the number of sides, or if you were to get a heptagon, or really a 9-sided figure like a nonagon or anything like that, the measure of the exterior angle would decrease while the measure of each interior angle would increase. So thanks for watching.